So 1, let me share this instead. All right, 1/6a was our, this is called polynomial, right? Solving polynomials. But we did ones to the higher degree. We did ones that were factoring by grouping. And then we ended with the super fun ones that were the exponents. That looked scary that we use substitution to get through, right? So if I look at that first one, we said we treat this almost exactly like we would if it was x squared and x, except it's x to the second and x to the second. But then after that, we do the same thing we do before, which is find the factors of positive 36 that sums to negative 37. What would that be? Negative 36, negative 1. Can I factor these further? Yep. This is the difference of two squares, x plus 6, x minus 6. Difference of two squares again, x plus 1, x minus 1. So there's 4 roots here, negative 6, positive 6, negative 1, positive 1. So if this is an open-ended question on the quiz, then I'll ask that you put it in order from least to greatest. So it would be negative 6, negative 1, 1, and 6. You will have the option of putting the answer on the work and letting me grade it there, or using, this one you would just be able to type in, but the other one is you can also use the equation editor to type it in.
I didn't simplify it, and I just did like the plus or minus square root.
That's fine. Yep, so you set it equal to 0 in here. As long as you remember the plus and minus. So the mistakes come there not remembering the plus and minus. If you remember the plus and minus, you're good. Okay, number 2, I've got 4 terms, right? So I'm going to factor by grouping. So I'm going to group these 2 and these 2. What can I take out of that first set of parentheses? Good. So then I get x squared plus 4. What can I take out of the second set of parentheses? 125. And I get x, this should be, oh no, that was right, x squared. There's a typo. That needs to be squared. Sorry. That needs to be squared. Should be x squared plus 4 again. Now I'm going to group together the x squared plus 4 and the x to the third plus 125. Can I factor either of those? What can I factor? Good, those are perfect cubes. So that first one can't be factored. I will solve it, but it can't be factored yet. Okay? And then cube root this, it's x. Cube root this, it's 5x. 5 squared, product, squared. And my signs, same, opposite, positive. You with me so far? So now the middle one I can already solve, right? That's negative 5. The one on the left, if I set equal to 0, I get x squared equals negative 4. X equals plus and minus the square root of negative 4, which is what?
2.
Good. Plus and minus 2i. So I've got those. I've got this one. And then I have x squared minus 5x plus 25. What do I do with that? Can you? How else do you solve something that's raised to the second power if you can't factor it? Quadratic formula. Yay! A is 1. B is negative 5. C is 25. Opposite of negative b, so b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Take the I out here. This is 3 and 25. So I'd get 5 plus and minus. The square root of 25 is 5 all over 2. So I've got 5 answers here. Plus and minus 2i, negative 5, and then 5 plus and minus 5i root 3 all over 2. Which you can keep together, or you could separate that into 2 fractions. It doesn't matter. If this was an answer on my quiz, I would certainly take advantage of the fact that I would grade your work. You don't have to type that in using an equation editor. That takes a long time, and it's frustrating. So feel free to use your work. So you guys, again, I'll give you the opportunity to just take it on paper. And from home, You're going to submit your work just like you did the last time, and I can grade that work.
Can you show the answers for the first one?
Sure.
Okay, thank you.
You're welcome. All right, then we get to that last one, right, which was terrifying, but then we realized we could do substitution, and it's not quite so bad. Not that it's enjoyable by any means, but I don't think it's quite so bad. So I want to look and see if my first term is the square of the middle term, and it is. So I substitute. I will say a equals 3x minus 2 to the 1/3. Which means my middle term is negative 2a minus 3 equals 0. And the first term is a squared. There's nothing on the front, so I keep a as a. Can I factor that?
Mm-hmm.
Yep, factors of negative 3 that sum to negative 2. Good. And set them each equal to 0. A equals 3, and a equals negative 1. But remember, we're not solving for a. We have to plug this back in. So 3 equals 3x minus 2 to the 1/3. And 3x minus 2 to the 1/3 equals negative 1. Now, how do I get rid of a 1/3?
Cube.
Good. Cube both sides. So I get 27 equals 3x minus 2. Add the 2. 29 equals 3x. Divide by 3. 29 over 3. And then repeat that process for the one on the right. Get rid of the 1/3 by cubing both sides. 3x minus 2 would equal negative 1 to the 3rd, which is negative 1. Add the 2. Divide by 3. Questions on that one? So I know it, like in the beginning it was frightening, but it's the same process. When you have those things that are ugly, you can use substitution. So take out what is next to that middle, that whatever that middle term is, make that your a, and then square it on the front. Questions? We good? We awake? Sort of? Partially? Half? All right, 1/6b. So today we get into ones with radicals. So we're solving other equations. That's the 1/6 heading, right? Is other equations. Today's specific 1/6b is solving radical equations. So some of these are going to have 1 square root. Some of them are going to have 2 square roots. Sometimes they're on the same side. Sometimes they're not. Okay? Sometimes you can see a 3rd root, all that good stuff. So the goal for each of them is to isolate the square root. If there's only 1 square root, we want to isolate it by itself. Okay? Then square both sides of the equation and then solve what's remaining. Here's the big deal. We have to check all of these answers. And the way we check them is, remember like extraneous roots with when we had fractions, we had to see that the bottom couldn't be 0. Now with square roots, we have to make sure that whatever's underneath the square root would be greater than or equal to 0. Because we don't want to get i's when we plug our answers back in. Sometimes there's more than 1 square root and you're not going to be able to isolate it. You want to, if you have 2 and just those, you want to keep them on either side of the equal sign and just square both sides of the equal sign. Okay, but sometimes not even that works. But if you can isolate it, that's the easiest thing to do, is isolate it by getting it set equal to 0. Or equal to just the square root.
So an I, it's no solution.
So you won't have you're right, exactly. So these will be like real solutions. So when you plug them back in, you'll end up with a negative square root.
Okay.
Yeah. All right, so number 1 says x minus the square root. Oh, this shouldn't go all the way over. I'm on a roll. Hang on, the square roots. here should stop here. That one should stop there. Okay, it should look like that. Number 1 should say x minus the square root of 15 minus 2x equals 0. So the first thing I want to try to do is get just that square root on the side by itself. So if I add it to the other side, right, if I move it over to the other side by changing the sign, I get square root of 15 minus 2x. I get x equals square root of 15 minus 2x. Now, to get rid of that square root, I'm going to square both sides of the equation. And I get x squared equals the square and the square root cancel out, 15 minus 2x. As soon as you see that you have a squared and a non-squared x, realize you're going to be factoring. So I want to get everything to one side, most likely factoring if not quadratic, okay? And I want my x squared to stay positive. So I'm going to move this to the other side by making it a plus 2x and move the 15 to the other side by making it minus 15. Now I want to find the factors of negative 15 that sum to positive 2. Are there factors like that?
Yeah.
What are they?
5 and negative 3.
Good. Positive 5, negative 3. Split and solve it. Positive 5, negative 3. Split and solve them, and I get x equals negative 5 and x equals 3. So this is where it's super important to make sure you check. Okay? If you just circle those answers and guarantee it, it's not going to be multiple choice, but let's say it was, those would both be an option, okay, because it wants to get you. You have to go back to your original and plug them in. So I'm going to plug in a negative 5 here, and I get 15 minus 2 times negative 5, which is 15 plus 10 square root of 25. This is my negative 5. Here, actually, let me just rewrite it so it's neater over here. Negative 5 minus the square root of 15 minus 2 times negative 5 equals 0. So a negative 5 minus the square root of 15 plus 10, negative 5 minus the square root of 25, negative 5 minus 5, does that equal 0? No. So this one does not work. Then you check the 3. 3 minus the square root of 15 minus 2 times 3 equals 0. 3 minus square root of 15 minus 6 equals 0. 3 minus square root 9, 3 minus 3. Does that equal 0? Yeah. So I keep the 3, but I eliminate the negative 5. So you have to be so careful, and you have to make sure you check your answers.
I'm confused on what you did for the 15 minus 2x, what's above the 2x, was that?
So I started plugging that in, this one here.
So you plugged it in?
I started plugging that in, but it was hard, so I just rewrote it.
Oh.
Yeah, I just rewrote it over here. That was me checking the negative 5. That's me checking the 3. So the 3 works, but not the 5, which means I rule out the negative 5. So we rule out the negative 5, and we keep the 3.
So you just said you can only have one answer, right?
No, not necessarily. Sometimes you can have 2 answers.
But I mean, like, you can only have one answer.
Yes, you can eliminate one. You might be able to eliminate both. You can have no solution.
If you eliminate both.
You would say no solution, yeah. Okay, so 2, and again, that square shouldn't have gone all, square root shouldn't have gone all the way over. It should stop at the 18.
Okay, so you want it to equal 0, right?
You want it to equal whatever the equation says. So this time, you mean at the beginning, or you mean when you plug it in?
When you plug it in.
Yeah, this time it was equal to 0, so I wanted the left side to equal 0. But here it's going to equal whatever that is. I just want a balanced equation at the end.
Okay.
Yeah. So 2, what would be your first step?
Add the square root.
Good. Move that over there by adding it, right? So x equals the square root of 3x plus 18. Now square both sides. X squared equals 3x plus 18. Move everything to one side. I keep my x squareds positive, so I'm going to move the other ones over. Factors of negative 18 that sum to negative 3. Negative 6, positive 3. Split and solve them. And then plug back into check. So 6 minus the square root of 3 times 6 plus 18 equals 0. 6 minus the square root of 18 plus 18. 6 minus the square root of 36. 6 minus 36, which is 0, equals 0. So the 6 works. Then check the negative 3. Negative 3 minus the square root of 3 times negative 3 plus 18 equals 0. Negative 9 plus 18. 9. 3 minus negative 3. Minus 3. Negative 6 does not equal 0. So I rule out the negative 3 and I only keep the positive 6. Mm-hmm.
So if there's two numbers, is like the negative one gonna always cancel or that's
No. So Sophia just asked a good question. Is it always going to be the negative one that cancels out? No. Okay, sometimes you're going to be able to keep both. So you've got to check them. Questions on those two before we move on? Everybody's alive at home? Alive and awake, I should say.
I'm a little confused with the first step, or just the first thing of like moving it over. You're just adding it, and then how does the x become squared? You just
So once I add it, I want to get rid of the square root. And to get rid of the square root, we square both sides.
okay.
Yep.
So it just becomes okay.
Okay, go to 3. My square root is already isolated, right? So what's my first step this time? Square both sides of the equation. So it's easy on the left, it just gets rid of my square root. On the right, that is not 2x squared minus 1 squared, and it can't distribute a squared, right? So you have two options. One is expand and FOIL that out. 2x minus 1 times 2x minus 1. There's also the shortcut. Remember from the power of, like if you raise something to a power, it's square the first term, so it'd be 4x squared. Square the last term, negative 1 squared would be 1. Double the product. So this would be negative 2x times 2 is negative 4x. So again, that's a shortcut. If you don't know the shortcut, you got to FOIL it out. If you do know the shortcut, it's square the first one, square the last one, double the product for the middle. 4x plus 13. Again, I got an x squared, yes? So I want to get everything to one side. I'm going to subtract the 4x. I get 13 equals 4. X squared minus 4x. Yep.
Why did you subtract negative 4 if it was already? Why did you subtract if it was already negative? Why did you add?
Oh, I'm doing this side.
Oh, okay.
I would have, it would have put an 8 on the left.
Okay.
Yeah. But I'm trying to move everything to the side where the x squared is, so that stays positive. Then subtract the 13. And I get 0 equals 4x squared minus 8x minus 12. Now what? I got a factor. Can I do anything to make my life easier? Take out a 4. Okay, and by taking it out, I can take it out here. And then I can actually divide both sides by it, and it goes completely away. So I can't do that with a variable, but I can do it with a, well, that shouldn't be 13. I can do that with a constant, okay? I cannot take out an x and then divide by x and get rid of it, but I can do that with a constant. So now I get x minus 3 and x plus 1. So x equals 3 and x equals negative 1. Now what? Check them. Square root of 4 times 3 plus 13 equals 4. Nope, sorry, equals 2 times 3 minus 1. Square root of 12 plus 13 equals 6 minus 1. Square root of 25 equals 5. 5 equals 5. That one works. I'm going to do the negative 1. 4 times negative 1 plus 13 equals 2 times negative 1 minus 1. Negative 4 plus 13. Square root of 9. Negative 3. 3 does not equal negative 3. So I rule out the negative 1 and I keep the 3.
Could you have plugged in x to the other side?
Could I have plugged in? What do you mean?
Like, plugged in x for 2x minus 1 instead.
You have to plug it in both spots. When you're checking, you mean?
Oh, okay, I see what you did.
Yeah, you got to plug it into both spots. Yep.
How did you know you needed it to equal the same thing if you said on the opposite side of it, on the other side of the equal sign is 2x minus 1? Like, how was it?
That's why you have to plug it into both x's. So at the end, when you're checking, when you plug it back into the original, you want the left side to equal the right side. So if there's a variable on the left, you're plugging it into that. If there's a variable on the right, you're plugging it into that. Any x gets that one value.
Okay, right. And for the shortcut, does that only work if it's just boiling two of the same thing?
Yep.
Just so it's not.
It has to be squared. So whatever the binomial is on the inside doesn't matter, but it has to be squared.
Is that just if it's subtracted?
No, it works if it's plus.
Okay.
Yeah, that goes back to, like, it was way back, but our special products. Yeah. But we're going to do that a lot, so that's why I wanted to review it. Yeah, you're going to see a lot of it. Okay. So 4. What would you do first?
Add 1.
Good. Add the 1 because I want that square root to be by itself. And I get x plus 2. Now, square both sides. Cancels on the left. Let's use our special product on the right. Square the first one. Square the last one. Double the product. This time it's a positive 4 in the middle.
I don't know if this is just my canvas, but it shows the square root going over the entire.
I whited it out. I'm sorry. It was not. It was a typo. Yeah.
Okay.
It should be like that.
Okay, because I was like, what am I supposed to subtract?
Yeah, no. I'm wondering how often. I can't wait to see the next slide. I'm assuming I did that the whole thing, which is super fun.
So then you would only subtract what's under the.
The whole goal for that first thing is to get the square root on the side by itself. So because that minus 1 is not underneath the root, I move that.
Okay.
So again, x squareds and x's. I'm going to have to factor, get everything to one side, subtract the 6x and the 7. 0 equals x squared minus 2x minus 3. X minus 3, x plus 1, and this becomes 3 and negative 1. Now we check. So square root of 6 times 3 plus 7 minus 1 equals 3 plus 1. 18 plus 7 minus 1 equals 4. 25 minus 1, 5 minus 1, 4 equals 4. I get to keep the 3. Check the negative 1. 6, negative 1 plus 7 minus 1 equals negative 1 plus 1. Negative 6 plus 7 minus 1 equals 0. Square root of 1. 0 equals 0. This is the first time, but it will happen. I get to keep them both. Questions on those? So look at 5. What would you do first normally? If I square them, let's say I do that, right? If I square them, I have to square this whole side and then this whole side. So now I gotta FOIL it out, square root with square root, which can be done. It might be easier to put 1 to the other side, so let's take that and add it to the other side. I'm not completely eliminating the fact that I'm going to have to FOIL with a square root. It's just that I'm moving it to be on a side with a number instead of 2 square roots. So I do think that's easier. Okay, it doesn't solve our problem completely because we still got a square root in there. Left side, get rid of the square root, 2x plus 3. Right side, think about using your shortcut. Okay, so again, think about the shortcut here, right? 1 squared would be the first one. The square of x plus 1 would be x plus 1. The square root of x plus 1 would be x plus 1. And then 2 times the product. So 1 times the square root of x plus 1 is x plus square root of x plus 1 times 2, positive 2 square root x plus 1. So that shortcut's definitely going to save you time on those. Okay, so I squared the first one. Square of 1 is 1. I squared the square root of x plus 1, x plus 1. And then I double the product. So the product 1 times the square root would just be that square root. And then double it times 2 gives me that 2 square root x plus 1. Now combine some like terms. 2x plus 3 equals, this is 1 plus 1. So I'm going to do 2 square root x plus 1 plus x plus 2. Now what?
Wait, why'd you distribute it?
Which one?
The 1 plus the square root of.
So I had to square this side, which means I also had to square this whole side. So I could have expanded it and FOILed it out and then done first order, but I did the shortcut. Yeah. So even though we squared to get rid of a square root, what's wrong? We still have a freaking square root. So we got to get everything else to the other side now and square it to gain. So we're going to move x. X plus 3 equals 2 square root x plus 1 plus 2. Subtract 2. X plus 1 equals 2 square root x plus 1. Now I can divide by 2, but then I've got a fraction on the other side. I probably want to avoid that. So from here, I can actually just square both sides. When you have a product, so on the left, I'm going to use a shortcut, x squared plus 2x plus 1. On the right, I can do 2 squared, which is 4, and then the square root of x plus 1 squared, which is x plus 1. Took 2 times, but we got rid of the square roots. Sophia.
When you're doing the middle term in the shortcut, how do you get that? I'm confused.
Say that again.
Like when you're doing the middle term in the shortcut.
Oh, double the product of the 2 terms. So multiply them together. It's a positive 1 times x, and then double it.
Okay.
If it was a negative 1, it'd be a negative 1 times x, which would be negative 1, and then double it.
Okay.
Yep, so you keep the sign there. So I get x squared plus 2x plus 1 equals 4x plus 4. Subtract the 4x. Subtract the 4. X squared minus 2x minus 3. I feel like we've gotten this factoring question 8 times today. X minus 3, x plus 1, split and solve. And then I get to check. Yeah. Algebra 2 honors is hard. It's not, I say it's tedious, right? So this is, I know. Wait, did I write out the extra thing? I sure did. Talking and writing, not a good idea. That should just be 1. God bless you. You're welcome. Okay, 3 works. Now do the negative 1. It also works. So I get to keep them both. Questions on that one? Yeah.
I'm a little confused about what you did for the step, but
This one?
And it's supposed to be-
Yeah,
Like, what
or the
was-
one before that?
I think it's fault, like what happened there.
Okay, so I was here, right, it was this equals the square root of that. So to get rid of this square root, I had to square both sides. So we squared this and we squared this. So it was 1 plus the square root of x plus 1 squared. So I said you can either duplicate it, FOIL it out, or use the shortcut on that. The shortcut would be to square at 1, which is 1, square the square root of x plus 1, which was x plus 1, that's where that came from, and then 2 times the product, which would have been 1 times x plus 1 under the root, or just x plus 1 under the root, because it's 1 times a. And then that's where the middle term comes from. So the shortcut is square the first term, right? So we square 1, square the last term, we square the square root of x plus 1, and then double the product. So multiply those two terms together, you get 1 times square root of x plus 1, double it, so times 2.
So then if it's 2 square root of x plus 1, then what's the 1 and the x plus 1 on the other side?
Say that again?
If then.
That's the middle term.
2 square root of x plus 1, then what's the 1 and the x plus 1 on the other side?
That's the square of the, so you square the first, square the last, and then the middle term is double the product.
Oh, okay,
Does that make sense?
yeah.
Yeah, okay. I think we're going to get to do it again. Over and over and over and over.
So square the first, square the last, double the middle product,
That's the special product when it's squared. That's the shortcut for when it's squared. We're about to do it again if you're ready. I know. So fun. All right, we're going to move it over because I just want one root on either side. 1 plus square root of x minus 3. I promise it hurts less and less every time because you get more familiar with the pattern. Now we square both sides, yes? Left side, it cancels. Right side's our shortcut. So square 1, it's 1. Square the square root of x minus 3, it's x minus 3. And then double the product. So 1 times the square root of x minus 3 is just x minus square root of x minus 3. And then double it, it's 2 times the square root of x minus 3. Now get everything but the square root to the other side. So I can combine those like terms first and then move it, or move it, then combine, doesn't matter. 2 square root x minus 3 plus x minus 2. Move these two over here. X minus 3 equals 2 square root x minus 3. Square both sides. Shortcut now on the left. X squared, 9, and minus 6x. Because that's double the product. Right side, 2 squared is 4. Square root of x minus 3 squared is x minus 3. Distribute the 4. Move the 4x and the 12. Are there factors of positive 21 that sum to negative 10? Good. Negative 7, negative 3, set them each equal to 0. And then we would check. Well, I'm going to save us the hassle because we're going to get to the next example. They would both work. Questions on the process. Again, it's the same process over and over again. It just gets a little bit more complicated as you go. I know, it's like that. It hurts. It's not fun. It's not good for your brain. Imagine at least that you're staring at me I don't know if they're still alive at home anymore. It's a bunch of black screens. I can't look for the sense of panic in their face. It's not happening. I can't like look at you and be like, I know, I'm sorry. They're just on your own, hopefully awake. Yep.
So I'm a little confused. There's like two shortcuts. There's one for the squaring thing, and there's one.
No, we just used it twice.
Oh, you did? Okay.
Yeah, we used it once up here when we squared this, and then we used it down here when we squared that. Anytime you square a binomial, you can use it. Yeah, we just used it twice. All right, I'm actually going to skip these two. I'll work these out in the video because there's nothing new with these. Well, there's a fraction and an answer, but other than that, there's nothing new in the process. But I'll work through these on the video. It's exactly the same process. It's just that your answer has fractions on them. But I want to get to. All right, so for number 7, we're going to square both sides of the equation. So square this and square this. On the left side, I'm going to use that shortcut. Square the first, which is x plus 5. Square the last, positive 4. And then double the product. So negative 2 square root x plus 5 times 2 is negative 4 square root x plus 5. This is a plus. Combine my like terms there, and I get x. Positive 5, positive 4, plus 9, minus 4 square root x plus 5 equals x minus 1 squared. So this becomes, x minus 1 because the square root cancels with the square. Now I got to get everything except for that new square root to the left side. So I'm going to, to the right side, subtract the x and the 9. Negative 4 square root x plus 5 equals, this cancels, negative 10. Square both sides. Negative 4 squared becomes 16. Square root of x plus 5 squared is x plus 5 equals 100. Distribute here. 16x plus 80 equals 100. Subtract the 80. 16x equals 20. Divide both sides by 16. X equals 20 over 16, which is 5/4. Okay, for number 8. We're going to do the same thing, square both sides. 4x plus 1 equals, shortcut here, x minus 1 underneath the root squared is x minus 1. Positive 2 squared is 4. Multiply these two together, 2 square root x minus 1 times 2, and I get 4 square root x minus 1. Combine my like terms there on the right. Negative 1, positive 4 is positive 3. And then I'm going to get everything to the left side. So subtract the x, subtract the 3, 3x. Minus 2, this is gone, equals 4 times the square root of x plus 1. Square both sides again. Shortcut on the left, 9x squared, positive 4, negative 6x times 2, negative 12x. And then square 4 at 16, square the square root of x minus 1 is x minus 1. Distribute the 16 to x and to 1. Then subtract the 16x and add the 16. 9x squared minus 28x plus 20. Now we factor. So 9 times 20 is 180. Factors of 180 that sum to 28. Negative 10, negative 18. Factor by grouping. Take out the x here. Take out a negative 2. 9x minus 10 and x minus 2. Solve. 9x equals 10, x equals 10 over 9, and x equals 2. Remember to plug them both into check, and this time they both work. These. Oh yeah, it's actually not as bad. It's not, I promise. It's not as bad. It's just what happens if it's not a square root. So if it's not a square root, if it's a third root, what would you do with it? You would cube it. If it was a fourth root, fourth it. Take it to the fourth power. If it's a fifth root, take it to the fifth power. If it's raised to a fractional exponent, we raise it to the reciprocal. So if I had something that said x plus 3 to the 2/3, then we would take both sides and raise them to the 3/2. So we raise it to the reciprocal, okay? The process is, the equations are actually less complex because the exponents are a little bit worse. So it's like give and take. It's not as bad as what we just did. You just got to remember that part, okay? So then if I was to find, well, we'll get to it. If I have to find something to the 3/2, it means I have to square root it and then cube it, right? That's what we have to convert it into or the index, okay? But I'm going to show you. All right, so 9. I know, it looks bad. It's not, I promise it's not as bad. What's the first thing you have to do? No, before you do that. Move it, right? Now I cube it. Look, it's so easy. It's gone. Did you ever think you'd be like, oh yay, I only have to factor? Subtract the x. You can either do trial and error or first and last. Well, what do we normally do? You guys do like first and last, don't you? Mm-hmm. Yeah, so let's do that. 4 times 1 is 4. Factors of positive 4 that sum to -5. -1, -4. And then group them. Set them each equal to 0. 4x would equal 1, x would equal 1/4, and x would equal 1. And again, they both work. And they look worse than they are because if you plug them in, they end up simplifying, like those fractions end up simplifying.
You still have to check these, right?
Yeah. It happens less like, I'm trying to think actually if it ever happens with a cube root. You might be okay. The square roots are where the issues usually come into play. Or even roots, I should say. All right, so 10. Now I've got both of them raised to the 1/3. So I would still do the same thing and get the one to the other side first.
Oh, so these we don't have to check?
Yeah.
Oh, okay. But you don't? Yeah.
Mm-mm.
Just the fraction or the square root ones?
Anything with an even root. So a square root, if you saw a 4th root, you'd have to check the 4th root. Like if that was 1/4.
Mm-hmm.
Yeah. Okay, now I'm going to raise each to the 3rd power. Cancels out. 3x plus 7 equals 4x plus 2. You don't even have to factor this one.
You raise it to the 3rd power because that was the reciprocal.
Correct. All right, for number 11, now we're raising it to we're taking the 4th root of it. So to get rid of a 4th, we're gonna raise it to the 4th power. So these cancel and I get x squared plus 6x equals 2 to the 4th. 2 times 2 times 2, 4, 8, 16. Get everything to one side. Factor. Factors of -16 that sum to +6 would be +8, -2. And I get -8 and +2. Let's plug them back in to check. So 4th root, -8 squared plus 6 times -8 equals 2. 4th root of -8 squared is 64 minus 48. 4th root of 16, and 16 is 2 and 8, 2 and 4, 2 and 2, so 2 equals 2. That one works. Plug in the 2, 4th root of 2 squared plus 6 times 2 equals 2. 4th root of 4 plus 12 equals 2. 4th root of 16 again equals 2, and 2 equals 2. So both of these work as solutions. All right, 12 is also a 4th root. So even though it's written differently, raising to a 1/4 is the same as taking the 4th root. So I'm going to do the same starting step, which is raise it to the 4th power. 3x squared plus 52x, this cancels, equals 4 times 4 times 4 times 4, which is 256. Subtract the 256. And I want to factor this. So I can do first times last. 3 times 256. 768. Factors of that sum to 52. Negative 12 and 64. So I get 3x squared minus 12x plus 64x minus 256. Group these and these. Take out a 3x here. Take out a 64. X minus 4, 3x plus 64. Set them each equal to 0. X equals 4 and 3x equals negative 64. X equals negative 64 over 3. Again, would plug them both into check and would find that both would work. Okay, last up. 13, I've got x minus 3 to the 2/5 and then 4x to the 1/5. So what I need to do is get rid of the fractions in the exponents. So you can multiply by the reciprocal, but it's going to leave you with something because they're not the same on this side. If I did 5/2, I'd still have an exponent. So what you might want to do, or what you can do, is just raise it to the denominator, so 5th. So if I wrote that as x minus 3 to the 2/5 raised to the 5th, I'd multiply these out, canceling the 5's, and I end up with x minus 3 squared. Then 1/5 and 5 cancels here, and I get 4x. So use my special products here, x squared, positive 9, negative 6x in the middle. Move the 4x over, x squared minus 10x plus 9 equals 0, and x minus 9, x minus 1. I'd get 9 and positive 1. Plug them into check. 1 minus 9, or sorry, 1 minus 3 to the 2/5. 4 times 1 to the 1/5. God bless you. You can actually plug that in here, which would be easier. 1 minus 3 squared equals 4 times 1. Negative 2 squared equals 4 times 1, and 4 equals 4. That works. 9 minus 3 squared equals 4 times 9. 6 squared equals 36, and 36 equals 36, which also works. Okay, last one. I get 3x to the 3/4 equals x to the 1/2. So I want to get rid of a 3/4 and a 1/2. I'm going to raise both sides to the 4th to do that. Now on the left-hand side, that means the 3 gets the 4, as does the x to the 3/4. So here they're going to cancel, and I get 3 to the 4th, which is 81, x to the 3rd. And on the right-hand side, 1/2 goes into 4 twice, x squared. Get everything to one side. Factor out the x squared. Split and solve this. X would equal 0. 81x would equal 1, and x would equal 1 over 81. Two solutions there, 0 and 81. And that's the end of our lesson. I know it was a long one today. Have a great day.